Okay, well, thank you everybody for joining us today. As Ben said, my name's Peter Shirley. I'm an amateur naturalist and a retired professional nature conservationist. I'm a fellow of the Royal Entomological Society, and I've been dabbling with galls for about 50 years now. And I'm one of the co-authors of the Field Studies Council AID-GAP key to British plant galls. Although I have to say the bulk of the work on that is done by my colleague Margaret Redfern, who is an academic and a professional biologist. So the first photograph that Ben's put up is something that's very prominent just now. And this is typical of it, the silk button gall, so-called, because it's like a circle of golden hairs. It's a really beautiful gall. And it's caused by a little gall wasp called Neuroterus numismalis. And the leaf on the left is typical of the very heavy infestation that you can get. And I took a photograph very much like that a week ago from just around the corner from where I live. And there were just about 3 leaves on the oak tree concerned that were absolutely covered in these galls, and none of the other leaves had any galls on them whatsoever. It's very strange, but it is very prominent, and it's coming up on the Facebook site and all over the place now because people notice it and like it and put the photograph up. So that's good. It's a nice one.
Okay, thanks, Peter.
Yeah, this one is a little bit more obscure. Can you see my cursor on the screen when I do that?
No, because I'm in the share screen, so no, you can't, Peter.
Oh, right, okay. I was just running my cursor over the gall just to make sure people could see it. It's on the left bit. Yeah, there, that's it. Yeah, and it's a curling of the leaf. I'll come on in a few minutes as to how we define a gall, because some things are very borderline, like a lot of things in nature. The creatures and the plants haven't read the books, so they don't quite know how to behave. But we do consider this as a gall, and it's caused by a little sawfly larva feeding in the leaf. And it is indeed, it's Blenacampa phylocolpa, a long name for a very small insect. And that's quite common. Yeah, you see that on wild roses quite frequently. Yeah, and what's the next one? Yeah, the gall itself is a bit shaded here, but it is what's called a knopper gall, Casquerkas Calisis, and we'll have a look at some more prominent ones of those shortly as well. This can sometimes affect the whole of an acorn crop on an oak tree, and it arrived in this country sometime in the 1960s, so it's a fairly, like a lot of, quite a few oak galls, it's a fairly new arrival, arrived in my lifetime anyway, but we'll talk a bit more about that later. But that's a knopper gall. Then we have the crown gall. This is one of the few, the organism that causes this is a bacteria. And it's one of the relatively few gall causes that has a very wide host range. Most of them are very restricted host ranges. And it's an agricultural pest. It's commercially important because it can do a lot of damage to plants. But it's got a tiny causa, and it has a huge effect, particularly on trees like birch and oak and others. Agrobacterium tumefaciens is its name. Still, I think, I was saying to Ben earlier, I've got an idea it's changed its name, but I haven't got a note of the new name to hand. I may be wrong on that, so we'll stick to it being Agrobacterium for now. Okay, and sorry, my wife is trying to ask me something. They're not sitting in the car. If the come in here and I'll come to the door. Yeah. Yeah. So I'll give you the key. I'll give you the key. Right. Sorry. Yes. This is a little Goldmidge caused gall, Japiella veronicae. A very distinctive. And is Alan with us?
I don't think so. No.
No. Right. Okay. I just wondered. Normally, when you see this, you see quite a lot of it. You rarely see just one or two galls. You get a patch of speedwell, and there'll be dozens of these galls on it. And it's one of the ones you have to look down for. It's very easy to find galls on trees because they're at the same height as we are. But there's a lot of herbaceous plants have galls, and so sometimes there's some you have to get down on your hands and knees for. So this is one of the low-growing ones. And yeah, and this is another one on ground ivy. It's quite widespread, relatively common, and this is one of our Synapid gall wasp causes, the Pecinius Smyrnii. And I think this is called a lighthouse gall for some reason. I'll check that while we're talking later on. Come back to that. Yeah, and that's very typical. And there's
this is the one from Elizabeth that we saw briefly.
Yes, yeah. I think that is Brevitarsus. It does say it was Eriophyes or Aceria Brevitarsus. I think it's Eriophyes Brevitarsus. Let me just double check that. This is a mite gall, and there are a lot of those. And they can be quite difficult to tell apart, and their taxonomy is constantly changing. No, it's not Eriophyes or Aceria. It is Acolytus brevitarsus, a mite gall. And on the underside of the leaf, if you look, you'll find a patch of hairs. The Eriophyidae is the mite family, where hairs are associated with the growth of galls, and the mites live inside amongst the hairs, feeding on the plant tissue. That's that one. Was that the last one, Ben?
And then just the final one from me of a couple of weeks ago. Right.
I'm going to talk a bit more about the robin's pincushion gall in my presentation, but the one on the right is the pea gall. Now, this is one that you can't tell the species that caused it, because there are two species that cause galls similar to this on rose. One is Diplolepis eglanteriae, which this probably is, and the other one is Diplolepis nervosus, the Sputnik gall. And it's called the Sputnik gall because it has little spines on it, just like the original Sputnik had, if anybody remembers that. But the difficulty of IDing them is that you can have nervosa galls without the spines, and then it's identical to the eglanteriae gall. But they're gall wasps again, they're synapid gall wasps, as is the robin's pincushion gall causer, which is Diplolepis rosae. Yeah. Diplolepis rosae has been very prominent and quite frequently found this year. The pea galls are less frequently found. You have to look a bit harder for them as well. Okay. Yeah.
We'll go over to your talk now.
So this is a cut down version of the talk that I do for societies and so on. Called Galls Galore, seemed a good name for it. But what you're at now, by the way, folks, you know, you can have a bio blitz where you look for everything. And traditionally, the fungi people have had fungus forays, haven't they? Well, we have gall gatherings. So what you're at today is a gall gathering. So what is a gall? This is the fundamental question, really. What is a gall? Well, that's what a gall is. And it's initiated by feeding, usually, of a larva or an infection by a fungus, for instance, or a bacterium. And it has to involve an increase in plant tissue in some way, as it says there. And Ben mentioned leaf miners and a leaf miner event. Now, leaf miners cause damage that sometimes is very similar to a gall, looks very similar to a gall, but most of the leaf miners, all they are doing is eating plant tissue and sometimes moving it around. So there's no increase in tissue and there's no increase in cells. And they're excavating their own mines to live in. The mines, just as galls do, they provide a feeding place, and the galls provide food as well, and shelter for the insect inside. Not that that shelter is always very effective, as you will see shortly. So that's our definition, and that's why there are borderline cases where people can't make their mind up whether a gall is being caused or not. So you will find different publications. I've got a whole library here of gall books, as you would imagine. Different publications list sometimes different gall causes. Some are more strict than others at deciding what is a gall cause. And interestingly, galls can be caused by plants, in particular mistletoes, because where the mistletoe is rooted in its host's tissues, it does cause the tissues to swell and grow around that attachment point, which is called a haustorium. So, so there's a nice gall causer you can look out for in the winter in particular, and even decorate your house with at Christmas, mistletoe. Okay. These are the things that cause galls. The ones that we mainly deal with are the mite, insect, and fungus caused galls. But you can see that virus and bacteria are in there as well. And we've already mentioned crown gall, Agrobacterium tumefaciens. So here's a few examples of galls. This is a centipede wasp gall on oak, Andricus fecundata, which is called the artichoke gall for obvious reasons. The one on the right, the red swelling in the leaf petiole, is a Goldmidge on lime, Contorinium, which is a big genus of gall causers in the Goldmidge family, the Secudomyids. It's Contorinia tiliarum, tilarium. Then a rather attractive, almost flower-like gall, which is caused by a scale insect, a psyllid, on rushes, and it's called Livorum juncorum. It's not particularly common, but when you do see it, it's very distinctive, and you won't mistake it for anything else. And this one, well, according to my notes, this is a Dazzy Nuru, which is another big Goldmidge genus, Dazzy Nuru ulmaria on meadowsweet. But I looked at that this morning and thought, no, it isn't. I don't think that's a meadowsweet leaf. So that's a mystery. I've got to sort that out at another time. Then, right. So gall causes, I've mentioned insects and mites. So mites, especially the Eriofoidea, which I've talked about. Then we've got all of these different insects cause galls. Aphids, beetles, etc. Thrips is in brackets because there are no thrips gall causers in this country. There are in other countries, but not here. But we have lots of Goldmidges and we have lots of cynnipids. Interesting thing about the cynnipids and the few chalcids that cause galls is that they are exceptions in their family, the Parasitica, or their division of the Hymenoptera. The Parasitica are nearly all, as the name suggests, parasitoids on other creatures. But centipede wasps and chalcid wasps that cause galls are unusual in that they are plant eaters. They eat plant tissue. And here's an example of a Goldmidge gall, Semidovia. There are 3 of these closely related species, on the seeds of birches. So if you collect birch catkins and take them apart, then you will find this evidence of the Goldmidges that feed inside the seeds. And in the keys, we show you how to separate those 3 different species. And that's a very common but easily overlooked gall. This is where galls are found on most groups of plants, but especially over 90% on the dicotyledons. There's also a few fungi that are galled, one galled by another fungus, as it happens. And you can see there the 3 families that are most affected by gall causes. Then there's an idea of the numbers of different gall species on them. In terms of individual genera, Salix and Quercus have the most galls in this country. Hang on, I'm sorry folks, Ben understands what my issue is here. I just got to leave you for 30 seconds. Right, where was I? Right. This is on poplar. Now, you should find these still, as the leaves are coming off the trees. Have a look at the petioles, and there's a couple of species of aphid that galls the petioles of poplars, and this is Pemphigus pyrethica. And if you open this, you will find lots of aphids inside. Very easy to find and quite common. This is just where the galls are found on plants very quickly. As you can see, there's a small percentage found on the roots. So sometimes if you're looking for a particular gall, you have to dig for it. Otherwise, they will be on the above ground parts of plants. And this is a key time of the year, sort of through July, August and September, when everything's in full leaf, is when most galls are there to be found. But stem and bud galls are often more easily found in the winter when there's no leaves on the trees, because it's much easier to see the structure of the plant and to see the stems, the leaves, and indeed the buds, and see the galls or remains of galls. And here we've got a poppy head. So on the left-hand photograph, the narrow poppy head at the top is unaffected, it's not galled. And then on the bottom of the left-hand photograph and on the right-hand one, you can see that it's swollen, and you can see the cells inside on the right-hand side. And this is a gall wasp caused gall. It's caused by Aelax papaveris or papavera. And again, if you come across poppy heads, these are very easily spotted. There is another species that doesn't cause such a big swelling, which is more difficult to see. Very briefly, there are some complicated life cycles amongst gall causes, especially aphids, because of course aphids have very complicated life cycles, as you know. But this is the common, and it's been a good year for it this year, oak apple, Biorhiza pallida, which is a gall wasp, top left, a wingless agamic female. Top right is the gall itself. In the spring, it tends to be flushed with bright pink. And bottom left, of course, is the host, the oak tree. But we'll start bottom right, where it says winter. The gall there is a gall on the roots of oak trees. And the wasps that emerge from the oak apple are males and females. And they mate, and the females migrate to the roots and lay their eggs and cause galls in the roots. And those insects stay in those galls for 2 winters. So it's got a 2-year life cycle. In late winter, they emerge, and that's the insect top left, which is a wingless asexual female. And a lot of gall wasps have these two generations. They have a sexual generation, males and females, and they have an asexual generation, females that reproduce by parthenogenesis, and they don't need to mate with males. And those little wasps are about 4 or 5 millimeters long. They actually crawl from the roots right up the tree, along the branches and the twigs to the outer buds, and lay their eggs, which then develop into the well-known oak apple gall. Because it's a 2-year life cycle, there's no evidence of any crossover between the generations. So on any one oak tree where there are oak apples, you've actually got 2 entirely separate and discrete populations of gall wasps. And for this reason, you often find trees that have a good crop of the oak apples one year and none the next. So you get a good crop in alternate years, and that's because there's 2 different populations at work on the tree. There's an example of one lot of complications, and here's an example of some of the species concerned with the 2 generations. So top left is there's a genus of galls on home oaks, Quercus ilex, Plagiotrochus, and that's one of the Plagiotrochus galls. Then on the right, another genus that is quite common is Cynips, and these are hard-walled pea galls, Cynips divisa. This is another gall that you have to actually cut open to know which of 2 or 3 different species you've got. And going clockwise, beneath that we've got the silk button galls again that we saw earlier. And we've got the much more common and widespread Neuroterus quercus baccarum, which are called spangle galls. And there are another 2 species of spangle galls as well, but they're not on that leaf. And then bottom left, we have Andricus quercus radicus, the cotton wool gall, and you can see, I think, why it's called the cotton wool gall. This is not so frequently seen because it's usually high up on oak trees. If you've had a storm and there's a few high branches come down in the storm, it's always worth looking for these and other galls on those high branches. And this is another Cynips called the cherry gall, which again is quite prominent. Really bright red sometimes, and it's Cynips quercus folii. And these, they're different to the spangle galls because a lot of spangle galls will fall off the leaves before the leaves fall off the trees. And where people raise pheasants and other game birds, then the birds will feed on these galls. They're obviously like miniature meat pies to them. But Cynips quercus folii, the galls stay on the leaf often, and you find them in the leaf litter still attached to the leaf. And then one that we saw earlier, but this one's in a slightly better light, is the knopper gall, Neuroterus quercus calisis, which is very common and widespread now. And it used to be concerned that it would cause a decline in the population of oaks in this country because such a high proportion of the acorns were affected by it. Excuse me, but this hasn't proved to be the case, and it won't prove to be the case because in its lifetime, one oak tree will produce thousands, tens, even hundreds of thousands of acorns, and to maintain the population, every oak tree really only has to leave one successor. So it's most unlikely that anything attacking the acorns will affect the oak population. And in fact, there are loads and loads of other things that eat acorns as well and destroy their viability. And the final point in this that's always overlooked is that the population of oaks in this country, and indeed the population of most forest trees in this country, is almost entirely dependent on our activities as people. We plant them, we cut them down, we allow them to grow, we don't allow them to grow. And that has a much greater effect on their population density than any natural processes do anymore. We have no truly wild forests left in this country. They're all managed in one way or another. So there's some food for thought for you. If you want to argue with me about that, feel free to do so when we finish this. Complications within galls. It's easy to think that there's a grub in there eating away, and it pupates and emerges and starts the whole process over again. But in fact, there's an awful lot going on in galls most of the time, and there's a whole lot of particularly chalcid parasitoids which feed on the grubs inside. So if you take the common marble gall, which was introduced to this country in the 19th century deliberately, and I'll come back to that later on as to why people would do that. So there is a rather poor photograph of a specimen of the Gall Causes, which lives in the middle of the gall. But, oh, didn't mean to do that. Let's go back. But as well as the Gall Causes, which you can see sort of centre left, Artichoke Gall, there are two cynogous species noted there. They're also gall wasps, but they're not Gall Causes. They are what's called inquilines, and they are lodgers, effectively. They take over some of the gall tissue and feed on it themselves. And then all those other species that are mentioned there that you can see, apart from the cynogous, there's 4 cynogous species shown there, are all chalcid wasps that feed on the larva or feed on each other. So the arrows go from the source of food to the thing that's consuming it. So for instance, if you look at the top and you see a different centipede, Siroptris, which is another inquiline. So it's not feeding on the Artichoke Gall, but it's feeding on the gall tissue. But next to it, the Reinhardi, there are arrows leading to 1, 2, 3, 4, 5, 6 different parasitoids that have all been found living in this gall on that species. And in some galls, there are parasitoids of the parasitoids called hyperparasitoids. And so it goes on, and this is what goes on inside the robin's pincushion. Gall Causes are in the middle, Diplolepis rosae, inquiline at the bottom, Periclystus, and then a whole load again of parasitoids. And in this case, unusually and very commonly, there is an ichneummonid that is found in robin's pincushion galls, Orthopelma mediata. And if you keep one of these and breed it out, yeah, sorry, someone said something then. Never mind. Then you will get Orthopelma mediata, and that's what the inside of the robin's pincushion looks like. A mass of individual cells which will have the synnepids in and all their parasitoids. So that is, these are examples of gall wasps. The one on the right, the rather thick set one, it's typical brown or browny black hunched appearance gall wasps. That will be an andricus of some sort. And on the left is a Neuroterus, a much lighter and more slimly built wasp. But the way that you tell them from the chalcids is a body colour as well. Here's a chalcid with a long ovipositor and often a metallic green colour. But if you look at the wing venation, you'll see that the chalcid has a very simple single vein wing, whereas the synnepids have a more complex wing venation with several veins. So that's an easy way to tell them apart. Just a quick look at a few other galls. Willows and poplars have a lot of galls. Top left here is the red bean gall, which many of you will have seen, Eura proxima. Going clockwise, a Goldmidge, Rhabdophagus cinerarium on goat willow. And below that is Rhabdophagus calisis, also on goat willow. And and bottom left is Eura bridgemanii. Now, bridgemanii and Proxima are sawfly galls. So there's sawfly larvae inside those. They don't pupate in the gall, they fall out of the gall and pupate in the soil beneath the trees. And just one or two others. If you grow damsons or plums, you may suffer from this from time to time. Those sort of paddle-shaped things are a fungus gall, Tephryna paddy, which affect the fruits, gives them the name of pocket plums. That's their common name. There are these tongues that you find in the cones of alder trees, which are, oh, the name's just gone out of my head, Tephryna alni, so the Tephryna fungal gall. And here we've got a fungus on Alexanders. It's an introduced plant, but you frequently, although you've got no coastline, you might not find so many Alexanders in your neck of the woods because it's a common coastal plant. And this is a gall called Pecinius Smyrnii, which is often there in great profusion. And if you grow pear trees, you will undoubtedly have this one, which is Gymnosperangium fuscum. Slightly brighter orange when you see it on the tree than it is on that, than it looks on that photograph. And this one is a really important gall causer. This is Claviceps purpurea, and it grows on various grasses, including cereals. And it's known by its common name of ergot, and it causes a disease. If the cereal is milled and the ergot is not found and sorted out, then it causes illnesses in humans when they eat it. Fortunately, these days, they've got all the right protocols in place to avoid that happening. But at one time, it was quite common to be suffering from the disease caused by ergot. And I'm trying to remember the symptoms, but I can't offhand. Right, I mentioned already that the Nopper gall arrived in the 1960s. Well, since then, all of these have arrived. There's a better picture of a typical Andricus adult gall, a gamic female. So again, clockwise from top left, you've got Andricus grossularii, or glossularii, which is, all these are centipede wasps, which occurs now quite commonly. Top right is Neuroterus saliens on Turkey oak, which also causes a leaf gall, its alternate generation. And its alternate generation on the leaves looks like a little Cornish pasty on the veins. And if you detach it from the leaf, it will jump. And it's named saliens. Saliens means jumping. So there are jumping spiders, I think, called salises. And you'll have heard maybe of Mexican jumping beans, or Mexican jumping beans are wasp galls that the kids in Mexico play with because they literally will jump when you take them off the tree. Then bottom right, Andricus gemia, a little tiny but very pretty gall found on the bole of trees on nascent buds in the bark. And bottom left with two big exit holes, so these weren't parasitized. Andricus aries, which have these long, on the left you can see long tapering filaments coming off them. All those have arrived in the past 20 years or so. And this one has arrived in the past 5 years. This is a notifiable pest. If you see, you should report it to the Forestry Commission. And it's an entirely new genus of gall wasp for this country, Dryacosmus curriphilus, known as the Oriental Chestnut Gall Wasp. And where chestnuts are grown commercially, sweet chestnuts are grown as a commercial crop, this is a serious agricultural pest. We don't have that in this country, so although it's a notifiable infection, it won't really do any economic harm to this country, but it might affect a lot of the chestnut trees. And there is the wasp itself. In this case, it's a black wasp rather than a brown one. It's still got that hunched appearance. So that's a quick run through some galls. All of this information and more about galls are available here on these various websites. I can recommend the Dutch one, Bladminides, which has many photographs, and it's like an online encyclopedia. And for those of you that are interested in them, having mentioned them before, it includes leaf miners as well as Gall Causes. And we do have the British Plant Gall Society. Just one or two more sort of trivia things about galls while you're looking at those, and if you want to make a note of them. May the 29th was the birthday of Charles II, and it used to be known as Oak Apple Day, to mark the return of Charles II to the throne, the restoration of the monarchy. And kids used to traditionally wear a sprig of oak with a Biorhiza pallida oak apple gall in the sprig of oak on Oak Apple Day. And if they weren't wearing one, then their so-called friends traditionally would beat them with nettles. So you would do well to find an oak apple gall and wear it on the 29th of May. Galls have got commercial importance from a positive point of view. They were widely used in the tanning industry because oak galls in particular concentrate tannins in the gall tissue, and that's why marble galls were introduced to this country. But as hundreds of years ago, the East India Company's first charter listed what it was allowed to import from other countries, and in that list of imports was galls. Because they're so important. Until very recent times, the finest printing inks contained galls as one of their constituents, and banknotes and so on. The inks that we use for those always had galls in their recipe. They can be used to authenticate documents, because when the large country estates and landowners were self-sufficient, they made their own ink, and so they used galls on their estates to make their own ink. So every ink has got a slightly different makeup, and it can be analysed these days to see whether documents are genuine or not. The tattoo ink that's used, called Turkey Red, is made from a gall. But finally, on these sort of trivia bits, there is an aphid gall called, well, it's changed its name now, but it's known as Phylloxera, which came in from North America when vine stock was imported in the 19th century, and it devastated the French wine industry in particular. And it's said to have cost France more than the Franco-Prussian War cost it in the middle of the 19th century. It's still there today, but they have learned how to control it. But it had a huge impact on the wine industry. And finally, you probably know about these already, but we have the Gall keys that I've already mentioned, and we're working on a third edition, probably out next year. But then when we had the AGM in Llandudno Wales last year, we were saying to people, it'll probably be out next year. But we are working on it, Margaret and I, we're making progress. If you want to know everything about galls, and 20 times more than I've told you this morning, I can thoroughly recommend Margaret's New Naturalist, which is, the last time I checked, about £30, and hard copy is available as a Kindle book, and it is absolutely brilliant. It's everything you will ever want to know. And then if you want a quick reference book for some of our most common galls, then the Wild Guide British Plant Galls by Michael Chinnery, who's has been a member of the Gall Society for many, many years, and has written many books. You probably have some of his books in your libraries on insects and so on. And he's pulled together this wonderful collection of really good photographs. So those are the 3 books that I would recommend. If you search online, you will find many others. There's American books, Dutch books, German. If you want to spend £400, there is a book of keys called Plant Galls of Europe. You see Plant Galls of Europe in 3 volumes by a man named Hans Roskam, and that has got keys to all the galls that are known in Europe. So, but it is extremely expensive. The most expensive book I've got in my library. So there we are. I hope you've managed to take some of that in. Thank you for listening. Thank you to all those people whose photographs were included in there. Some of them were mine, the rest were these people's. And that's the end of my presentation, folks. I'm happy now to talk about things and take your questions. Okay, I'm back. I missed the first half of that. But you're obviously talking about what I was saying about the estates using the galls for their own ink and so on, yes?
Do you have the historical kind of record, or? I
don't know. I don't have a reference for it. It's just something that something that I know, so to speak. It might be in Margaret's book actually, but I'm trying to think where I got the information from. I guess it might be Margaret's book. That experts have certainly have analysed the ink in some way. But no, sorry, I haven't got a reference for it. But I didn't make it up either. I mean, in those days, I don't know which galls they would have used, to be honest, because the main ones are the marble galls. And there's a lot of similar species in other parts of the world, the Middle East in particular. So there's a group called Aleppo galls, for instance, and they were the ones that were imported by the bushel. And none of those would have occurred in this country sort of 400 or 500 years ago, and neither would Nopper galls. And another tannin-bearing gall is on Sumac in China, and that was commercially important in China for the same reasons. In fact, that's the galls on the Sumac concentrate more tannin than any other galls in the world. So no, sorry, I can't throw any more light on that.
I'll do a bit of chasing up.
Yeah, I'd be interested to know what you find out. But yeah, but they certainly have been, as I said, they have been very important in trade over the years. Not so much now. I think we have more synthetic inks and dyes and stuff like that. And I'm not aware that they're still imported. They were still being imported back in the 1960s and early 70s. I know that. Because the Bank of England had a very rigorous criteria for the inks they used for our banknotes. And I think it's either Germany or Finland. I think it's Germany. Until 20 years ago, this particular sort of ink had to be used by law for their banknotes. So they were a key constituent, key component. And the reason, by the way, that we were importing galls to this part of Europe is because one thing we haven't talked about is for Phylloxera galls on oaks. Is that oaks are getting on towards their northern limit of their range here in northwest Europe, because oaks as a genus, the Quercus, is really a semi-tropical genus rather than a temperate genus. So the world's epicenter for the variety of oaks is Mexico, which obviously is a much warmer country than here. And it's a very large genus, Quercus. There are dozens and dozens of species of oak. And we only have 2 native species in this country, Quercus robur and Quercus petrea. And touching on that, the complicated life cycles of the gall wasp that I talked about also includes alternate generations on different species of oak. So all the ones that have arrived here in our lifetimes, they have one generation on Roba and or Petrea, and their other generation on Turkey oak, Quercus ceris. And Turkey oak wasn't introduced to this country until I think the late 1700s. And it's, as you know, or you may not know, but it is widespread now. It was planted and it's self-generating and so on. And it's the presence of Turkey oak that has enabled the establishment of all the new synapid species, because they need both Turkey oak and English oak to succeed. So, I mean, we could do a whole other workshop on introduced species, which is another hobby horse of mine, but I won't go into that now.
Thanks, Peter. We were chatting with Vivian about the sweet chestnut and the gall that affects the sweet chestnut.
Yeah.
Does that gall only affect sweet chestnut?
Yes.
So it wouldn't affect horse chestnut as well?
No, because horse chestnut is an entirely different genus anyway. But you see, talking about introduced species, it's a notifiable pest because of its effect on sweet chestnut. But sweet chestnut is an introduced species. You know, this is where you're moving towards my hobby horse, so we're very inconsistent about these things. No, one thing I should have said during the presentation is that apart from things like agrobacterium that we've already discussed, gall causes are in effect natural genetic engineers because they take over the host's metabolism to produce a growth that is abnormal, wouldn't normally be there. And in the case of oak trees in particular, and other trees, the phytochemistry going on is very complex. The layers of tissues that they build up and the tissues that they feed on. And because of this, they tend to have very narrow host ranges, sometimes just to a species. Now, Dryocosmus might affect other things in the genus that sweet chestnuts are in. I don't know, I've not checked. But they are either single species or a single genus or a closely related group of genera, which is one of the ways that helps to identify them from the gall, because certain things will only produce galls on certain things. So that helps with the identifications. Yeah. There is, I must mention, another very widespread group of galls, though, which we identify collectively as a Bacterium Gall. And those are the nitrogenous root nodules on legumes. What are legumes? The Fabaceae now, aren't they, legumes? They changed their name a few decades ago, didn't they? So you know that they're used obviously in agricultural systems to put nitrogen back into the soil. Well, those are galls caused by bacteria. So that's another commercially important, but positively commercially important set of gall causes. Did you collect any other questions for me?
Elizabeth had one about the marble gall.
Yeah.
Did you want to ask, or do you want me to?
I couldn't remember whether you said, Peter, which part of the world marble gall was introduced from.
Oh, well, marble galls were in northwest Europe, mainland Europe, so they didn't have far to come.
No. Seems strange we didn't already have them.
I suppose it might be. Yes, maybe just nobody thought of it. Somebody had a light bulb moment one day and thought, hang on a minute, I've just been in France and they've got all these marble galls. Why aren't we bringing those in instead of bringing stuff in from the Middle East, which is where the main centre was the Middle East and further south. So I don't know, but I do know that there were the same concerns about the health of the oak population when they were introduced and started to spread rapidly, because it's now one of the most widespread and common galls there is. So it took off very quickly, as things tend to do when they first arrive in a country. I mean, now it's acquired the whole guild of parasitoids and so on, and so the population is now more naturally controlled than it would have been to start with.
So have any of the introduced species, have any of them brought in parasitoids which have had any sort of effect on native species?
Yes, yeah. I mean, the Nopper gall has got parasitoids in this country now. The presence of the parasitoids, well, there are two forces at work here. The channel is not very wide, and gall wasps and chalcid wasps are very weak flyers. So they do form part of the aerial plankton. So I think they depend more on the wind to blow them about, to distribute them more widely, than they do with their own volition. So if insects like a gall wasp arrives in this country and succeeds in forming a gall and establishing a population, if it's one that's blown in, then it probably won't have any, well, it won't have any parasitoids with it. But what we have now, though, is human activity, and the nursery and horticultural trade moves huge quantities of trees in particular around the world from country to country. And so undoubtedly some gall causes have come in on horticultural stock, and in that case they will have their parasitoids with them because the whole system is being moved. So now, I mean, for instance, if you grow fuchsias, you are likely to get the gall on fuchsias now. And that has undoubtedly come in with the horticultural trade. It never used to be in this country. From memory, I think it's a might be a midge. I'll just look that up for you. So that's the answer to the question, really. So what you might call adventives arriving here won't have parasitoids with them, but plants arriving with galls on them will have the parasitoids with them.
But do we know whether they're having an effect on the numbers of native gall wasps, for instance, or?
No, there's no evidence that that is so. I mean, just like the gall wasps themselves, or the gall insects themselves, are very choosy about which species they live on. Each species of gall causer will have its own little guild of parasitoids. And there'll obviously be crossover. Similar galls will have similar parasitoids, but then that's all to do with the size of the parasitoid, the length of the ovipositor, the stimulus to lay eggs at all, and that's all to do with the shape, the size, the smell, the thickness of the gall wall, and so on. So physically similar galls you would expect to have to share the same guild of parasitoids, but otherwise, no, they won't go about parasitizing everything there is to parasitize, because they won't have the equipment to get in, so to speak, and they won't get the right cues from the environment to try to lay their eggs. I said earlier that none of the species in nature read any of the books, but that doesn't stop them being apparently very clever about what they do how they do behave. And I know it's not cleverness, I know that's an anthropomorphic label, but you know what I mean. You know what triggers them to do things it's very complex, very complex. Let me just tell you what the fuchsia thing is. I think I've got it here, maybe not, but I'm fairly sure it's a mite. Yeah, it is a mite. Aculops fuchsiae, so it's named for fuchsia, which thickens the leaves at the shoot tip, and it will be coming to a garden near you at some time in the not too distant future, I suspect.
And is it a great problem? I'm just thinking about the fact that parts of Ireland are very rich in wild fruit fuchsias. I mean, I have an Irish friend who can't believe that people grow fuchsias since she can pick them wild in the hedges.
Yes, that's right. Yeah, I've not seen them myself, but I know about the fuchsia hedgerows. I don't think it's going to cause the fuchsias to die out. It disfigures the plant. And so if you're growing them as an ornamental plant, then it's probably not welcome. But then, you know, if you're a gardener growing either fruit, vegetables or ornamentals, then, I mean, you're having a constant battle really anyway, aren't you, with whatever wants to eat them, disfigure them, or whatever. So it's just one more thing to deal with. I obviously I'm the other way around. I look for the galls in my garden and obviously quite enjoy having them, except for the ones on my neighbour's plum tree, because I end up getting hardly any plums because of Daphrina paddy, the pocket plum. The tree's got that, I'm afraid. But there we are. I put up with that because I'm a gall person.
I was just wondering, when you said about them importing galls, what life stage would they import? Do they get the actual gall wasp?
Yes. Well, they just get the galls. They would ignore they'd ignore the insects inside if there were any left inside, I suspect, because they just grind the gall up and mix it with whatever they want to mix it with. In fact, in Margaret's book, there is a recipe for making ink. And some people in the Gall Society have experimented themselves with making ink by grinding up Artichoke galls. They're the best ones to use in this country. Yeah.
But did they import the adult gall wasp, or
no? They imported the galls.
No, I mean when they were introducing the actual species into Britain.
Oh, well, I would still think that the only practical way of doing it is to import the galls and to leave them in appropriate places. So if you import the adult wasps, you might be able to get them to lay their eggs by sleeving the branches and you know, containing them in that way. But I think it'd be a very hit and miss process, to be honest, and nowhere near as effective as getting a bushel of galls and just throwing them over the forest floor or whatever. And leaving them to find their own way.
Right.
By the way, you can tell, looking at these galls with the parasitoids, you can tell if the Gall Causes has emerged or not. Like, do you remember I showed you the Andricus aries galls with the large holes in? The Gall Causes, if they succeed, they come out and then there's just one hole in the gall because they've been in there and they've not been attacked and they've come out. But the parasitoids and inquilines, when they come out, they have much smaller exit holes and there'll be more of them. So you can tell a certain amount about the history of a gall by looking at an old gall and looking at the exit holes in it.
Okay. Great, thanks, Peter. Any more questions from anybody? If you are muted and you did want to ask a question, you would have to unmute yourself. There's a few people.
Just while people are thinking, I'll just say a bit about the history of galls. The oldest known gall is a fossil gall on a tree fern found in Illinois, and it's 300 million years old. So they've been around a long time. And it's thought it was probably caused by a sawfly of some sort. Mark knows. Hello, Mark. And then there are other galls have been found of younger age. So gall wasps and gall midges are thought to have evolved with flowering plants, started in the Cretaceous period between 140 and 70 million years ago. And then there's a group of very attractive flies that cause galls in thistles, the Tephritids, called the picture wing flies. And they feed in the seed heads, in the achenes and the seed heads of thistles and burdock and other closely related plants. And they started about 34 million years ago. But if you, the most prominent one of those is in the stems of thistles, the big swelling in the stems of thistles, Urophora cardui. And they're very attractive insects when they come out. And if any of you are familiar with North America, Canada and North America, in my sister's garden, for instance, in Ontario, she's got the globe galls, which is a taphritid fly, on Canadian goldenrod, grown in its native place. So they're very common in Canada, and everybody knows about them over there. But if you look at thistles in this country, particularly this time of the year, you might see some swellings in the stems. Or if you take apart the flower heads of thistles and burdocks and knapweeds, then you may find the galls inside. They're very insignificant galls, and you might see the larvae inside there as well. So that's a bit about the history of galls. They've co-evolved with the plants that they live on, which is also another reason why they're very fussy about which plants they live on, I suspect. Because you know how evolution works, you go from being a generalist to a specialist to being extinct. And a lot of galls are at the specialist stage, probably for the next 50 million years before they die out, unless we kill them all off, of course. It's what David Attenborough is going to be telling us tomorrow night, I suspect.
Can I ask her?
Yep.
I always had this theory that knapweeds, I don't know whether it's a common name all over the country, where I used to live, we used to call them hardheads. And I always used to wonder whether it came about because of the ones that had the, I've never read about it anywhere. And I just
yeah, I'm glad you said that. You remind me, that's one way of finding the galls actually, is to squeeze the heads of knapweeds. And if the head is hard, the chances are those are the galls inside, and you can open that one and you will see the galls. Yeah.
Do you think that's how they got their name, hardheads?
That's how they got their name, yes.
Yeah. Yeah.
Yeah.
Okay.
Yeah.
Right.
Yeah. Thank you. Yeah.
One thing, Peter, I always say to people when I'm trying to explain the gall is that the gall egg or the larva exudes a hormone which affects how the plant grows and then gives rise to the gall. Is that correct, or are there various different ways that it causes the?
That is still a subject of debate. It's certainly in some cases it is hormones or enzymes in the saliva of the larva feeding, which stimulates the plant to produce the gall. I think that's the most widely accepted mechanism. But because most of these things are not commercially important, there's nobody doing the research really, although there's a friend of mine in the Gall Society who's always experimenting with biochemistry and so on. He's been working on mites recently. If you look on the Facebook site, you'll see his photographs of mites leaving the mite galls, which is very interesting. So that is certainly a mechanism. And one interesting thing about the mechanism, and keep returning to oak galls, and you must remember there are, as they say on the BBC, many other gall groups available. But it happens that oak galls is the group that I've particularly studied. But they do cause the plants to produce things that they wouldn't normally produce. So nopper galls and another gall, Ambricus grossularii galls on oaks as well, when they grow in their early stages, they are sticky. They're producing a nectar-like substance. And this is on an oak tree, which is wind pollinated and doesn't naturally produce anything like nectar. So that's how profoundly they are changing the metabolism of their host. They're not just producing extra tissue, they're producing stuff that the plant wouldn't normally and doesn't normally produce. It's remarkable, really, when you think about it. Now, whether that stickiness is produced as a defense, because if you're a parasitoid prospecting for an egg-laying site, you're not really going to want your feet in sticky stuff, are you? You're going to find it difficult to move about. So I suspect that's what it is. And particularly as it comes in the early stages of the gall, when the larva is most vulnerable, and the gall tissues are at their softest, because as the gall matures, the tissues get harder and harder, and that in itself then forms a physical barrier to the parasitoids being able to drill into the gall and lay their eggs. But that is that's one of the most remarkable things about them, I think. What they can do, not just the pustules and the lumps and the bumps, but actually things that the plants would never normally do. This is why they're so fascinating, and why we were on a debate about this the other day with another member of the Gall Society, and he said, in the end, he said, why are we so interested in them? And I think it's because, I mean, I got interested in them because as a young father with 2 jobs at the time, as it happens, galls were something in the natural world that I could study almost without leaving home. I didn't have to do field trips and so on. They were in the garden and they were in the park and they were around about. So they're easily accessible. Kids love them. They're very interesting to kids. They're very tactile. You know, you get hard ones and soft ones and squishy ones. And they've all got a story to tell. And every story is different amongst all the different Gall causes. There's about 1,500 Gall causes we know of in this country. And they've all got a different story to tell about where they are, why they're there, what they do, whether they do have an important effect, either good or bad, on the plants that they're on and so on. So it's a really fascinating subject. Well, some of us think it is anyway.
Right. Always nice to have a story with something.
Yeah.
And it aids the memory of it as well. So
yeah. Oh, and they are eaten in some parts of the world as well because of this sweetness that they sometimes cause the plant to exude. So they can be eaten. There's a gall on corn and going back to Mexico, that part of the world, Central America, that is actually cultivated because it's good to eat. I think that's a fungus gall. I don't think you eat the grub inside. Although that wouldn't matter, because a lot of the world does eat insects. It's just us here in Northwest Europe, really, that doesn't, and North America. Yeah, so sometimes they're used as food as well.
Okay. Excellent. Any more questions? I think that's probably it now, Peter. Great. Well, that's brilliant. Thank you very much. Yeah, that was a nice discussion at the end there as well. So they are quite amazing things, these galls. So yeah, I must develop my interest in them. And
yeah. It becomes second nature once you know about them. When you're on a walk or whatever, you sort of subconsciously, you don't realize you're doing it, but you're sort of looking for them, and then you start seeing them, and you know, oh, there's a so-and-so, and there's a so-and-so, and there's a so-and-so. Yeah. And there's a lot of galls on grasses, caused by chalcids in particular. They're quite difficult to find, but there are a lot of them. So grasses, herbaceous stuff, trees, bushes, shrubs, yeah, they're all over the place.
And are they easily identified with a photo? So you could put a photo up on a...
Some of them are. A lot of them are. They're quite distinctive. I mean, that's another thing about the sort of genetic engineering, is forming these complex growths on plants, which are sort of stable over a long period of time, and all different to each other. So quite a lot of them are, quite a lot of them aren't. There are a lot of mite and midge galls on leaves, which superficially all look the same, and so they're more difficult to do from a photograph. But of course, having said what I've said about them being choosy about their hosts, there's galls on leaves, you might find a lot of plants that could be half a dozen different ones, and you might do with a photograph, or you might have to look through a hand lens, or even breed them out. It is not easy to breed insects out, but it can be done. The gall wasps are easier than the Goldmidges for that, to be honest. So yes, some of them you can, and going back to recording and people using a camera to record their observations, that's one of the things about validating galls, is whether the photograph is going to be good enough for some of the more critical or species that look a lot like other species. But the host, identifying the host, is the single most important pointer to what gall you're looking at. And often on the Facebook site and so on, people put something up to be ID'd and they say the host is bramble for argument's sake, which has quite a few galls on it. But then someone else will respond and say, well, I've looked closely at your photograph and that's not on bramble, that's on alder or whatever. And it's very easy in a tangle of vegetation to mistake the plant you're looking at. You know, you can see a massive blackthorn for argument's sake. And so you just assume what you're looking at is on the blackthorn and you don't look closely enough to realize it's on something that's going through the blackthorn. That's a very common error that people make. It seems very elementary, but you know, it's very easy to do. Very easy to do. Mm-hmm. Yeah. Identify the host. So you need to be a reasonably good botanist a lot of the time to take it to the next stage. And that's where most people come to galls from. They come to galls from botany rather than from entomology, to be honest. Although I did it the other way around. I was always interested in insects.
Okay, good tip. Okay, that's great, brilliant. Thanks.
Okay.
Thanks for sharing your knowledge. Hopefully we'll get a few more gall records in and more interesting galls. And yeah, thanks everybody for joining.